Okay, I've been working on a metal detection circuit. Well, actually, what I would like to build is a battery-powered hand held metal detecting wand that could be used for security purposes. At an airport or anything. Just trying to build a real simple one. Maybe that runs off of a rechargeable battery. And so, looking on YouTube, I came up with some ideas. There's so many different circuits for metal detection, from as simple as using a single 555 timer or a single 3904 transistor to supply a oscillating frequency, which gets shot into a coil. So, and a coil generates a magnetic field, and when a magnetic field comes within range of metal or a magnet, the impedance changes of the coil a little bit, but there's changes in the frequency which can be detected, and that's how this circuit works. Here's the circuit I made on Circuit Wizard. It's just two 3904 transistors, two coils, and in this case it's not a transmit and receive coil. It's just two coils approximately the same frequency, and when a metal comes near the two, the difference in frequency is amplified through, I guess, like a summing amplifier, and the two transistors form. I think something along those lines. Anyways, I built the circuit. Here it is. Here's L1, L2, and this is about 80 turns of 32 gauge copper insulated wire. And there's the scope signal. I altered this circuit design a little bit because it was acting as like two separate circuits. You had L1 and L2, and in order to see a change on the output, both coils had to simultaneously see a metal or something. But I altered it a little bit by joining the collectors of the transistors together, and so I have two separate coils that can act individually or together. So if you're looking at the waveform, and I put a piece of metal in the coil or around the coil, you can see the change in amplitude. That's L1, coil 1, L2, same thing. The first time I built it, it could only work on one or the other. So I shorted together the collectors, this little yellow wire right here. And by the way, this is about 0.5 microseconds times where's the horizontal position? 0.5 microseconds. Now we'll change that a little bit. 1, 2, 3, 4. A little over 5 divisions at 1 microsecond. So about 5 microseconds, which is what I think about 200 kilohertz, 200 kHz. Pretty high frequency, but not real high. I guess they have found that range of frequencies works best and is the most sensitive to metal. So it's a pretty simple circuit, just using two 3904 transistors, a capacitor and a resistor to get to that get that 200K frequency. I was going to try to amplify the output so I could put it through some sort of audio device, a speaker. As it is right now, if I plug in a buzzer or something, it's a real weak, faint, high-pitched sound. Obviously, you really can't hear it because 200K is well beyond the range of the human ear. But I guess I'm picking it up octaves or something. I don't know. If I put it on the output, I put this buzzer on the output. you really can't even hear it. Let's see here. I'm just trying to plug it in temporarily. Let's see here if I go like this. Nothing. This buzzer does have polarity, plus and minus. I wrote it out on the back of the board. Yeah, but you can't even get any. You can't even hear it because it's too high of a frequency. Let's see if I can do it again here. Plug it in. Oh, where else can I tap into it at? All those holes are taken up. Oh, right here. There we go. Okay, so plus goes to the minus in this case. There, you can hear it now. You hear a change in the frequency. So if you were waving a wand around along someone's body, in my case, let's say I put this C-clamp in my pocket, and then I took the coil, you could hear it change. Let's see, this coil, not quite as long. Hear it?